1, 2. Hello. No. I'll use my voice. Oh, here we go. Well. Good afternoon. Hello. Hello, everyone. Good afternoon. On behalf of the Faculty of IT, we'd like to welcome Google back again. Before I can say anything, can I get everyone just to kind of scream and say hello? Now, do it now. Hey! Right, in true IT fashion. All right, well, a good speech, it's a short speech, so please give a warm welcome to Google.
Hi, everyone. Hi, Monash. Welcome. It's so excited to be here. This is such a great crowd. I always love coming here. Thanks for having us. So my name is Stephanie. I run our outreach programs at Google, so all of our internships and student outreach and initiatives to bring amazing, awesome students like you into Google. We also have our student ambassadors, our Google reps on campus, Chantel and Tina, who helped with today's event, and you'll probably hear more from them throughout the year. So thank you both. So I also brought with me some Google engineers from the Sydney office. I'm going to have them introduce themselves to you at the end, but we have quite some time for Q&A, so I want you to take this time to think of some really tough questions to ask them at the end. And we actually have some of these prizes to give away if you have some good questions. So start thinking of your questions now. So I quickly showed Google's mission, but too fast for anyone to see it. So I want to see if any of you actually know. Can you tell me what Google's mission is? Anyone? Yes, you in the back. That was really close. There's a... That was close.
Can you catch? Can I throw is probably the better question.
Oh, that was really close.
Sorry.
Yes. Thank you. Thank you. Thank you for your participation. So that is correct. You were so close. To organize the world's information and make it universally accessible and useful. So that's a really important mission. I think it's a big mission, and it's a mission that we can't do alone. So we need your help to do that. We are a growing company, and we're growing and trying to do this. And if you ask anyone at Google, they will be able to know that mission, because sometimes there's a lot of different products coming out. We started as a search engine 15 years ago, and now there's so many more things. But the idea behind all of these products is to have one beautiful user experience to make life easier for you as students. So hopefully some of the products that you're using as a student are making learning fun, making it magical for you. Quickly, just a little bit about myself, because I think people at Google have some pretty interesting backgrounds. But I actually started in New York office about 7 years ago, so I've been here a few times. And I actually spent a semester studying in Melbourne. I've also worked in Singapore and Sydney. So we actually have offices in over 30 countries, 60 offices in over 30 countries around the world. So for those of you that like to travel like me, there's quite a few opportunities to do that. I like my house music, so if you know some good music, we can talk later. And I'm a pretty big travel junkie in terms of adrenaline sports as well. I like lights going back and forth for effect. I also studied at the University of Maryland, so I'm a big Terps fan. I asked this question yesterday and nobody knew. Does anyone know what a terrapin is? That's our... A turtle! Wow! So many of you know. So I'm a big Terps fan. I love sports. So a little bit about the history of Google. So 15 years old as the company grows, a lot's been changing, but it's kind of exciting to see what's happening. So I wanted to share a little bit about the history of Google with you, because over the last 15 years, there's a lot of exciting things that are happening. So with that, a short video. So the idea for Gmail came from one Google employee is what we call ourselves. So now 425 million people are on Gmail. And there's 1 billion Android mobile phones throughout the world. How many of you guys have an Android phone? Whoa, yeah. That's crazy. That's cool. Glass, has anyone tried Google Glass? Oh, a few of you. So Google Glass is not yet in Australia, but hopefully coming soon. So lots of exciting things happening, and I think what's really neat about the company for us is just really to see what's next. A little bit about Google culture. So Google's not a conventional company. We have offices all around the world, as I said. Have any of you been to a Google office before? A few of you? Former ambassador? Yes. So we have a pretty interesting office. There you see our office in Sydney. So that's a picture of the Sydney monorail. And one Googler said, hey, wouldn't it be cool if we had the monorail in the office? So our facilities team said, yeah, sure, why not? So there we go. The Sydney monorail is now in our office. So pretty interesting. Lots of people ask about the office. Is it true that you actually have free food? Yes, we have breakfast, lunch, and dinner. So I can come in the morning, have breakfast. In the afternoon, I can play in the games room. I can have a nap in the sleeping pod. I can take the kayak out for a spin. I can actually recently took the kayak out with one of my colleagues for a kayaking one-on-one, and she actually fell in the water and lost her phone. But otherwise, productive meeting. And so, yeah, the office is pretty unique, but really it's about fostering collaboration because people come to Google not just for the perks that you hear about on TV and in the movies, but also because they actually work on real products. They work on really exciting things that affect millions of people. So the scale is huge, and people really love what they do, so that's the reason that they come to Google, because they want to work on things that really do change the world and are going to affect so many people. There you see some of our offices, very colorful, but again, just that collaborative nature because it's over coffee, over in the cafe, it's playing pool, that those really great ideas come to be. Another unique part of the company culture is the trust and transparency within the company. So TGIF is something that's been happening for 15 years, which is, thank Google, it's Friday. So every Friday, there you see back in 1999, Larry and Sergey, our founders, are taking questions from the audience. So just as we're doing here, this happens in California every single week. So they don't miss a single week. And Larry and Sergey take questions from anyone, so you can ask absolutely anything. And also they do demos and things happen during the week, and it's live streamed throughout the world. So that's something that's pretty unique. A lot of the information that's shared with employees is really, really interesting stuff that you'd get to hear before the public. So again, our mission is a big one, so we can't do it alone. We are growing. We have offices throughout the world. We are hiring, but I did want to mention that in Sydney we have about almost 1,000 people now, half of with makeup engineering, the other half make up some of our other functions like sales, marketing, PR, HR, and those areas. And we're growing, so we're looking for students like yourselves who are interested in making big things happen. So some of the products that we work on in Sydney are Maps, we have the apps team, Chrome, Blogger, Google+, App Engine. We have network engineers. We have engineers working on the Go programming language. We have engineers in test. And we also have site reliability engineers that keep things running. So lots of opportunities. We also have internships. So if you're currently enrolled in a degree or you're going to be studying, we're looking for interns. So this past summer, we had a lot of interns in the Sydney office. And so if you intern with us, we pay for your relocation, we pay for your housing and organize everything for you. So we don't have an office here, but we do have an office in Sydney, and we're looking for people to come and spend 3 months with us in the summer and have a look and check it out for yourself. So for interns, the deadline is June 1st. So you'll see in the next week or so on our student site, google.com/jobs/students, and we have cards with the site there on your way out. And that's when we're looking for you to apply for internships. So we have a few different internship programs. One in particular is specifically for first and second year students from historically underrepresented groups in computer science. So some of those groups might include women, students with disabilities, students from indigenous backgrounds, students from the LGBT community, because we want to see our employees as diverse as the population. So that's something that we're working on, and we hope that this program will help do that. With this program, you work in a team, you work on a project, but you also have a mentor, and you're going to work on a project where each week you'll be getting professional and technical skills as well. Again, we provide relocation, and also we are open for international students. If you're interested in other internships in overseas offices, still apply to Sydney, and we'll sort you out in terms of what sort of preferences you're looking for. I'm going to show you another quick video from our interns in Sydney, just sharing some of their experiences over this past summer. Hit it, DJ.
The first time I saw the campus it was incredible. There's volleyball nets
This
and
is Mountain
colorful
View.
umbrellas.
We'll show you Sydney.
Just jokes. Just kidding. It's fun.
Thank you.
I think Google is self-driving cars and balloons that send internet to everyone. So my name is Sarah, and I'm studying software engineering and public policy at Macquarie University, and this year I'm interning over the summer at Google. As I was growing up, my parents kept telling me that internships were just making coffee for people, so I was a bit hesitant about my first internship.
When you walk in, you get up the elevators here in our building and it's bright yellow, and immediately that kind of sets the tone for everything. People are very focused on a balance between working and having fun, and the office really facilitates for that. There are games and there are plenty of places to go and relax when you need a break, which you always do when you're working really hard. I'm Andrea, and I'm an intern here at Google. I'm a first-year computer science student.
Our tale today tells the story of two EP interns, Flo, and I'm Andy.
I'm Florentia, you can call me Flo. I'm also an intern at Google, and I'm also like a first-year university student.
Okay, next one's yours.
We are actually like an engineering practicum intern here in Google. It's like an internship program that is focused on like the underrepresented group in software engineering.
The really cool thing is we're working on the products. We're ingrained in a team, we're embedded in there, and oftentimes these projects will go to launch, which I think is absolutely unbelievable.
One of the challenges we have at Google is trying to find the next generation of people who are going to come and work here and help us achieve the really ambitious projects that we're working on. My name is James McGill, and I manage 3 teams that work as part of the bigger Google Maps product. But I started at Google Sydney in 2007 as an intern, as part of Google Australia's internship program.
Interns bring a fresh perspective. Their enthusiasm is contagious throughout the office. Hi, I'm Stephanie Borgman. I manage our internship program here at Google Australia. We're really excited about the fact that our interns are from all different backgrounds.
I think girls in engineering are a little bit of an endangered species, and that there's really not a lot of us around.
So this is where we come in. We were summoned to Google Castle to find a solution to this awful dilemma.
Google is an organisation that aspires to really reflect the global diversity. We always find it's an amazingly vibrant, exciting time of year when we have our interns descend upon us.
Hi, I'm Renee. I'm a former Google intern. I worked as an intern with my manager, Mike.
My name is Mike Lawther, and I'm the Chrome Product Area Lead here in Sydney. When I'm trying to figure out what interns would work well on the Chrome team, what I'm looking for mostly is some sort of spark, some sort of passion in there. We had one intern who came in and she applied very late in the program because she wasn't sure if she should apply.
And I really didn't know what I wanted to do. I didn't know if I wanted to move away from home, and I didn't know if I wanted to come into the big city. I think if I hadn't done the internship, I may not have had even the confidence to try and get a job at Google. It definitely gave me confidence and skills that helped me to get the job.
coming to Google, you see that the people who work here, really what they have in common is this passion for technology, for making things better.
Some of the best advice someone gave me before I applied for the internship was you'll never get anything that you don't apply for. You never know, you could be sitting here next.
So a lot of the folks you see here actually started as interns, so you can ask them some questions at the end about their experiences. So again, all of our internship postings will be up soon on our student site. If you're graduating at the end of the year and you're thinking about what you're going to do next, there's also some full-time opportunities in engineering, and we have quite a few different kinds of engineers in Sydney building some really cool things. Those deadlines are May 1st. So start thinking about how to put together a resume and what you might want to tell us. The process for interviewing with Google looks like this. So if you're looking for an internship, again, upload your resume and you would have 2 phone interviews, technical phone interviews with Google engineers. If you're looking for a full-time opportunity or grad position, after 1 or 2 phone interviews, we would fly you down to Sydney for in-person interviews with engineers, and a decision will be made by our hiring committee, and we'll get back to you. So again, on our student site has some tips on how to put together a resume and also on interviewing and how to prepare for technical interviews. A few other things I want to mention. We have some cool programs. So again, I spoke a little bit about the diversity internship program. Another opportunity we have for women. We'd like to see a more diverse group of people in this field. We'd like to see a better gender balance in the field of technology. So we do have a scholarship. Anita Borg was a visionary and a pioneer in computer science. And her goal was to have 50% women in the field of computer science by the year 2020. So that's pretty soon. And we're going to help try to achieve that vision that she had with the Anita Borg Scholarship. $5,000 scholarship for women. So women in the room, I hope you do apply. Men in the room, I hope you encourage women to apply. The deadline is May 18th, but the really cool part of the scholarship is all the scholars that are chosen, and we'll have a handful from Australia. We would fly you to Tokyo for a all-expenses-paid scholars retreat to connect with other women in the field. Really cool opportunity. Encourage you to apply for that. A couple other things that are happening is Code Jam is an online coding competition where you compete online in code. So really good practice for interviews as well, but really cool prizes. It's actually open now, and the deadline is in April. So for Code Jam, the top 25 will be flown to LA, all expenses paid as well, to compete for Top Coder of the Year, which is a $15,000 prize. Also, the AdMob Student App Challenge, and I know the ambassadors ran an event on AdMob as well, and this is a challenge that's currently taking place. The deadline to submit an app is at the end of the month, but we're looking for students. This is exclusive contest just for students to build an app where you would learn to make money with AdMob. So you'll get your app on Google Play, and there's also a trip in it to our headquarters in California where you can see our 23 offices and self-driving cars and all the really interesting things happening in California. Again, all the information for students is on google.com/students, so I encourage you to have a look and see the types of things that you might be interested. Thank you so much, Monash. That's all you're going to hear from me today. I hope you have some good questions for the end of the session, but for now, I'm going to hand things off to one of our extraordinary Googlers. His parents called him Arya, but we call him Growly. Here you go. Thank you.
Hi. Hi, everyone. I need to do some admin. Here we go. And that is not the starting slide. That's not the right screen. So, the title of the talk is How I Learned to Stop Worrying and Love Graph Theory and Linear Programming. This was my first project at Google after I joined, but I'll get to that eventually. First, a little bit about myself, because I know you guys are students and may or may not be, as I was, a little bit confused as to what to do and where to go after you've finished. This photo is of me at a protest, which is irrelevant, but the sign is the most versatile sign I've ever created. And I will use it regularly. So the opinions I express also are not Google's, they are my own entirely. That's my cat. I was born in Wellington, New Zealand, and I lived between New Zealand and Iran during the first 22 years of my life. I went to Victoria University in New Zealand, and I studied electronic engineering. Although my degree had 3 or 4 different names by the time I graduated, it was basically electronic engineering. There was calculus and signal processing, and I built an amplifier. After that, I wanted to do a PhD, but I couldn't really figure out what to do it in. So I did a couple of internships. I went to ANU in Canberra, and I did a 2-month stint there doing boring stuff like reading a textbook. Actually, it's an interesting story, because as soon as I got there, no, this isn't ANU's fault, they're lovely, but as soon as I got there, my supervisor had to leave, and then the only other guy who knew anything also had to leave. So that happened. Then I went to Google for an internship, which is a great program, and there I ended up on the network infrastructure team, working on the project I'm about to talk to you about for 3 months, and I had a really good time. You know, even though I was actually off-season, I didn't have any other interns around to hang out with, I still had a really good time. And that convinced me to defer my PhD plans until I had a better idea of what there was out in industry and what kinds of problems needed to be solved. So I applied and successfully converted to a full-time engineer. Of course, not without the modern middle-class drama of too much choice. I think drama is like a dilemma. And that actually began continued my lifelong journey of self-discovery that I'm nowhere near finishing. So I understand if you really don't know what's going on. Because people, they're not straight with you. They just want you to do what they tell you to do, right? But anyway, we'll get to that. The problem we solved has very humble roots. Networking is just fantastic. Like, this family is extremely happy, right? They have a home network probably because they can share things with each other and print them out and share files and watch them on TV or whatever. And then, how many people here have been to a LAN party? Those are great, because everyone just sits in the same room for like 48 hours, not really moving much, but playing computer games. And that is one very good example of how much fun networking can provide, right? Aside from the obvious like power inherent to connecting various autonomous devices that can perform computation and whatnot. And then, of course, there's commercial and even bigger networks like that one. That's not Google's. I don't know where that's from, but it's pretty typical of the mess you see in a server room. The internet is an example of a very big network. So networking, great, love it. I think we're all in agreement. Unless it's not, right? And this is funny, because I was looking for this picture this morning. I looked up stock family photos while I was preparing the presentation, about an hour ago, and it failed to load. And it was perfect, because when it goes wrong, it goes pretty horribly wrong, and you just sit there scratching your head being like, where's the other half of the toddler, right? What do I do? It's beyond my control. There's so many layers of abstraction behind this that I can't fix it myself. So how do you find the problem? Well, you check what's in the fridge, because that's what I always do. It always holds promise. Then you eat your feelings. You might go for a run. You might clean your room. You might ask your mom, because she knows everything else. But ultimately, it fails. So the standard approach in the real world, quote unquote, is to do something called using white box monitoring. You simply ask the devices to tell you what's wrong. You say, dear device ABC, tell me how many interface counts you have for packets going between X and Y. And you trust that it doesn't lie to you. You trust that it tells you the right answer and that it has successfully accounted for every single packet that has crossed the link, and that you can deterministically, on that basis alone, pinpoint the fault. You can guess that that's not always the case. Sometimes routers have real bugs in them and they break, and you can't do anything about it. They leave blind spots in how they monitor things. Sometimes problems are so nefarious that they'll only occur between one node and another node through a specific node at a certain time on like a Wednesday, right? And that's very hard to pinpoint, and it's very hard to track down. So you have other options. You can guess. You can guess intelligently, or you can pay experts to guess intelligently because they're experts. Yeah. But being Googlers, we didn't really think this was good enough. We thought this was a bit of a pain. We have a fleet of network engineers who are extremely good at what they do, and they studiously observe the network day in, day out, around the clock. They have shifts that follow the sun. And it is a pain for them to sit, even when something goes wrong, and think, what could possibly have caused it? They rely on a lot of domain knowledge and a lot of domain expertise that has been slowly, painstakingly, agonizingly built up over the last 18 months of their tenure. And then eventually they figure it out. It'd be nice if they could devote their time to more awesome things like creating bigger and better networks, right? So there has to be a better way. Ideally, and I have to apologize again, because these slides are from a publicly presented talk at Apricot, which is an ISP conference in Singapore last year. I haven't been able to change them because that would mean having to get them revetted for public display, and they're kind of irrelevant. So ignore most of the text. It's kind of the vague ambiance of the slide that you want. Listen to me talk. So ideally we want something that does all this for us. It finds faulty links, and it doesn't cry wolf often, right? It doesn't provide so many false positives that engineers just stop paying attention. We want something that gives some indication of severity so that they know whether it's worth getting out of bed or stopping drinking whiskey or, putting the beer down. That's not what we do. And we ideally would like something that provides this higher level information. It provides long-term analysis. It provides, so for example, we know that certain links going through certain countries where certain freight liners often troll and certain times accidentally cut fibers. We know that this is a problem and that we should work around it. This would be ideal. Yep. Well, this is relevant so far. Imagine if you could dictate the path that every packet took down to like every hop, every way. And this is basically source routing, it's called. If you could do that, you could create a bunch of paths that sort of intermeshed. And the intersection of how they intermeshed in different nodes, right, that would dictate in the event of a fault which node was faulty. You would test all the paths, you'd send ping packets, and you'd see which failed. And you know because, say, A, B, and C failed, that they all shared a common element, that it must be that common element, right? That is awesome. And here's an example. So there are the paths with different colors and line decorations. And then imagine that link breaks. Then all of a sudden you see you see the 4 paths that go through it show errors. And you're like, oh, awesome, I know where that is, done. But real life is hard, right? Real life presents multiple problems that occur simultaneously. And as soon as, as soon as there is more than one fault on the network, everything you knew about the other fault is void, unless you work around it somehow. So what we did is we modeled the graph, the network as a graph, because it is, and because, we're studious engineers with solid foundation in theory, and we love maths. Then we, I'll get to that later. I'm still trying to elaborate why this is bad. Okay. You have these other problems too, right? You have these problems like routers have different constraints on them. They have different limitations imposed by different vendors adhering to different levels of standards because they don't feel like it at the time. And some of them are quite quirky. Things like some routers can only have 10 paths across them. Some can have 200, right? You need a way to incorporate all of these things into a single solution and to provide it well. And all of a sudden you have this complicated engineering thing that you have to do. So we had to build a thing called a correlator, which is on the next slide. Yeah, it's the multiple faults thing. Yeah, it's boring. Right. Yeah, we built a correlator. And the correlator is the thing that has to determine, based on the result of failing paths, what is the single cause. We tried by doing the obvious thing, right? You take the list of paths and you remove all the non-solutions, the things that are obviously wrong. And then you try and account for partial failures because failures aren't black and white. For example, a failure might affect one path but not another and not all the time, but generally it affects most of the ones going through a specific node. Then we tried to iterate on this. We did things like having paths that had errors in them leak errorness to other paths that go through the same node. And then we'd end up with heat maps that are really cool to look at, but mostly too vague to do anything with. So our network surveillance team was like, this is ridiculous. We can't actually use this. What are you doing? So then we thought some more, and we realized that basically what we're writing is a linear program. Who knows what a linear program is? No. Thanks, Ian. So, how can I put it? A linear program basically is do you know what a system of linear equations is? Okay, never mind. There are a bunch of equations. There are a bunch of equations, and you can frame this problem in such a way that every equation represents a path and the failing elements within the path. And then, I kind of have a whiteboard, but a coefficient is assigned to every element which represents how much of a failure it is at what it's doing. And then you tell this linear program to iterate over the solutions to this, or something close enough, so that it minimizes how wrong that is given what you know about the paths. So you can learn about this later, but mostly linear programming is awesome. Basically, this objective function, once run, will yield a bunch of nodes with a bunch of different numbers in front of them that are non-zero, and they tell you what is the most likely set of elements that failed once you, given your data. And that is how we build a correlate. Any questions? Good. Oh, is that one there? Sorry, yes?
Basically, you would calculate the eigenvalues of that linear system.
Oh, I don't think, you can't call them eigenvalues, I don't think. But it's hard to tell you because I haven't shown you how we exactly formulated the problem. That's because it's proprietary. But yes, it's similar. If you learn linear algebra, you will see how this works. Do linear algebra. So then we had the second problem, right? We needed to build the set of paths in the first place, and that's actually another very complicated problem. But knowing that we're going to use a linear program to try and solve them, and we're trying to, we understand the kinds of inputs that give better results, we had some idea of where we should start. Again, ignore that. But basically, we had to sit down and figure out what is a good set of paths, right? How do you know what you should be probing? We had a lot of trial and error again. We knew we had to keep the paths very small, because that would mean that if one broke, it didn't affect the chances of everything else on the same path being useful. And we had to work within a lot of router constraints. And I mean a lot. Like, I wrote the first version of this as an intern, and then I spent 18 months afterwards working on the same thing. So I'm going to gloss over it, but the real world was quite unkind. It is NP complete, which means it's super hard to figure out the answer. But it basically reduces to a cover problem. I don't know how much computer science you guys have done, but you should do more. But basically, it ended up meaning that we had to maximize the resiliency of every path. Like, we had to, in some way, make it that if paths A through C failed, then paths D through J99, which relied on the same nodes, would still be useful for something. Which means that every path had to give you more and more information, which means we had to increase the entropy, really, of the set of paths we had. Who's done information theory? You should do that too. Yeah. In the end, basically by doing this and iterating and constantly, like, we'd pick a path. So the algorithm goes something like this. You pick a path, and then, you pick an element, and you beat a bunch of paths to it, and you make sure you avoid all the other paths around it, and then you iterate, and you pick different probers every time, and eventually you have a set that basically satisfies all these requirements. You can add, like, a salt, for example. You can just add more paths because you want more entropy, or you want more data. We defined a mathematical model for this based on the probability of a path failing and the usefulness of what was left, based on the size of the sets of nodes through every path, if you're interested in that. But I can't show you that either anyway, actually, never mind. But it worked. It worked really well. We had multiple approaches, too. There was another approach where we literally just randomly generated paths and then checked them. And that was valid. I mean, it wasn't guaranteed to do anything useful, which is kind of uncertain, and actually really upset management. But it worked, right? Now, this is the good part, we can automatically pinpoint a fault by running the system within 30 seconds of it happening. And we can tell you that going from port A to port B on switch 3 in China or India or London is the cause of the fault, even though you're nowhere near there and you can't actually go down and check. Sometimes it could be someone, in fact, there are pretty classic examples of like, for example, network failures where a contractor will go and try and install cable in some suburb, and accidentally while they're installing it, their crane will fall on the overhead fiber that goes across the same. I don't know why it's in like a suburb, but anyway. Yeah, so that cable will get cut, and then the engineers are like, well, what? We just lost, I don't know, several hundred gigabits of bandwidth. But now we know. We can say it's between A and B, and it happened at this time. What else happened at that time? So it's pretty cool. Talk through all that. Yeah? There are exciting future possibilities, too. In the future, we can automate the system, and we can get it to self-heal the network. Have you guys heard of SDN? Thanks, Ian. Ian has. He's really good. So that's software-defined networking. That's basically where you take the intelligence out of the router and you put it in a centralized controller. And you say, dear controller who knows everything about the entire world, please direct my paths from afar. Like, tell my packets where to go based on varying network conditions. And if you incorporate this system as response and feedback, you can tell it to automatically heal the network. You can dedicate bandwidth where it's missing, or you can preempt certain problems. There are other advantages. For example, the routers are tested in exactly the same way that regular traffic uses them. The problem with white box monitoring that I mentioned before is that you're asking the router to be very honest about things it really doesn't know anything about. It can't generate a packet and then have it go out, loop back, come back through its own interfaces, and then treat it as a normal packet and then do this, like, somehow have it return. That doesn't work. But with the system, you get that result. So it's actually really great. It's great. And that's it. Are there any questions? Are there any sort of questions? Wait, Ian.
Why do people call you Growly?
Ah. Okay. So when I joined Google as an intern, the recruitment lady called me. Her name is Mel. She is lovely. And she asked me what I would like my username to be. I asked for Aria, which is my first name, which would make a lot of sense. And she said that was already taken. Turns out, I find out later, by someone who'd already left the company. Grr. But being short for time, a little bit stressed because I was in the middle of my exams and not knowing what else to do, I simply gave her the username of my private email address, which is the one I've had since I was 9. So it comes from Pokemon. Awesome. Thanks. I didn't really spend a lot of time on my background. Is there anything particular you guys wanted to? It's more or less. Yes.
I'm also an electrical engineer. I'm curious when you learned computer science stuff enough to be doing solving large-scale linear programming problems.
Ah, I'm glad you asked. So I didn't until I joined Google. I learned a lot of computer science, and I did my interviews and before that a couple of other software engineering internships on the basis of my first and second year of computer science and my dabbling in it in third year. So my problem was, and this is kind of related, is that I wanted to do everything, right? I wanted to go and do physics, and I wanted to do maths, and I wanted to do all the other things, and like French. But I couldn't. I overloaded 4 semesters, and I had a really bad time. And then I ended up in the middle of the final years of my engineering degree, which I don't know what it's like at Monash. I'm sure it's fantastic. At the university I was at, because it was the first iteration that they'd done, and in their defense, it's fixed now. But they made us do a lot of papers that I didn't understand the need for. So I ended up not being able to pursue it as much as I wanted to. But in between that, I did try and fit in as much as I could. I ended up doing an honors project that was like modifying the driver in the Linux kernel to reorder network packets. Because, secret, I actually also did a network engineering degree. It's a really long name, so I leave it out. And that involved learning a lot about Linux and the kernel and the computer science at that level, right? Like the sorts of data structures used there. Then I did a really good internship, a really, really fantastic internship at a small company in Wellington called InnoWorks. I wrote a Java to Flash translator. So it would let you run Java programs in a Flash virtual machine because, surprise, they're basically the same bytecode, it turns out. Or there's a one-to-one mapping between most of the instructions. That taught me a lot. And actually, if I'm more honest, it was a bit of a painful summer. But I did it, and I learned a lot, and I felt great. And then I applied for Google, and on the back of that experience, I managed to get through the interviews. I really cherish, actually, the first and second year papers more than anything, because they were the introduction to the idea of algorithmic analysis and the importance of different data structures and the trade-offs you would otherwise ignore. There. Now, I think everyone else can answer questions, too, if they all come up and introduce themselves.
All of our engineers.
I'm Ian. I'm a software engineer on the Google Drive team and Docs and stuff. I went to
I'm Dimitri. I'm another software engineer on network infrastructure in a different team.
I'm Jen. I'm a software engineer also on Google Drive, but I work primarily on Android and mobile. Oh, and I was an intern before starting at Google New York, and then transferred to Sydney about a year ago.
Is it my turn? Yes, a question.
Well, James, I'd like to know what your working hours are like.
What the hours? Working hours. I get in 9:30.
So working hours are very flexible, right?
Oh, yeah.
They give you the ability to sort of manage your own time as long as you are getting your work done. It doesn't really matter when you come in and when you leave. Sometimes it's done on a team-by-team basis based on sort of when your team meetings are and things, but I've definitely worked with different teams and different people who tend to work best during parts of the day, and we just work around everybody's preferences.
I have a nap after lunch every day.
For a while I didn't have many people to work with because there weren't meetings in the morning, I'd turn up at midday and leave at 10 p.m.
I'm the opposite. I get in every day about 7 and leave at 4:30. Weird.
Hey folks, we should introduce ourselves. I'm sorry we're late. We found your fish and chip store. I'm James McGill. I am a senior software engineer and a manager of a couple of teams in Google Maps in the Sydney office.
My name's Dave. I work in Geo as well, but in developer relations.
I'd also like to add to Aria's note about how networks fail. Networks fail for really, really strange reasons. Like in Canadian hunting season.
Oh, yeah.
Yeah. Do you want to elaborate on that one?
I don't know if this is the same story you were going to say, but I think someone shot a cable once. That actually happened.
They've got like yellow, like bright orange things on them, and then shooters, hunters when they're bored will just try and hit them, and then they cut out fibers, and then some poor sod has to go out into the middle of nowhere in Canada. It's like crazy.
Yeah.
And refuse
everything, and it's bleak, and there's like less cat videos being distributed, and it's terrible for everyone.
There's one involving a cat.
That's not fun.
Yeah.
More questions?
Is there any networking internships right now?
No.
I don't think so. Do you know the answers to that? From knowing the network engineers, most of them are, they have quite a lot of experience working for ISPs or other large network providers. I've never seen a network engineer intern.
But there's definitely internships working on stuff like what Growly does, which is the software components of networks. And like what we know at Google is that the software can be hugely impactful, and if you have good algorithms and good implementations, you can seriously improve the productivity of your network infrastructure. So there's definitely opportunities there.
Are there opportunities on pen testing and cybersecurity?
Are there what, sorry?
Opportunities in penetration testing and cybersecurity?
Absolutely, yeah. Google employs a lot of security engineers. I think pretty much all of them are fairly active in the broader security community, so they post on all the mailing lists, they get involved there. If that's something that you're interested in, do exactly the same thing. Become part of that community, and that's probably the best way to get started.
Over here.
What would a first-year student who hasn't got much experience yet do at Google as an intern? Is there a lot of on-the-job training?
Yeah. So I posted EP interns the past 2 years. So our EP interns are the first-year students that I mentioned earlier from the underrepresented areas. Those students usually build a project that's slightly smaller in scope from a typical third or fourth-year student, but they work with a partner. So some of the projects include things like we did a an Android app that demos some products. We built a third-party library that had heat maps on a map. James worked with some students who created a tutorial to teach you how to use some of our products. Other people have done network visualization software. So there's another couple who worked on a ticketing system to kind of, when people have problems, we have them file a ticket, and it walk you through, oh, are you filing a ticket because of this? Oh, here's your machine. I noticed that it's underpowered. Can I increase it for you? Try to solve those problems. That's the sort of projects that people do in first, second year.
So
when they come online, they'll get a lot of help as well with the senior engineer. But
my two EP interns who you saw in the video, Andrea and Florencia, they did their project all in JavaScript and HTML, and they had not touched either piece of technology at all before coming to Google. We held a lot of training courses to teach them that, and GitHub and version control and similar systems, and they absolutely rocked it. What Google looks for isn't necessarily someone who has a particular skill or knows a particular language already, but people who are enthusiastic about technology and good learners and really committed to learning. And we just assume that you'll get ramped up quickly, and if you've never touched a programming language before, it won't matter, because if you're enthusiastic enough, you'll just overcome that barrier. Up the back.
Sorry?
No idea.
I don't know. I think.
No idea. Up the front.
This is a question for Ian and Aaron. How do you scale concurrent connections across the network? For instance, 2 people using Google Docs in, like that's just 2 people, but then if you have hundreds of thousands of people using,
You mean like load balancing? I don't know how much of that's public. So I'm going to say vaguely.
Talk vaguely about
Vaguely, caches, and if you split the problem into much smaller units, so if 2 people are using a dock, but only 2 people are using their dock, they can just have their own server, for example. If 20 people are using a dock, and there happens to be a really intense dock, then they can have all of one server. Stuff like that, right? It's quite complicated. It's not that simple. It's it's a huge problem.
With docs, it's not as simple, but like generally how there's a few basic load balancing techniques. One is just round robin, so you've got 10 servers, and it'll just go to server 1, next request goes to server 2, next request goes to server 3. You've got then more complicated and smarter ways to do that, which adding sort of feedback loops, if you've done any like control systems, which basically ping the server going, how much traffic do you have? Oh, you're at 10% load. You have more queries, etc. So you have more and more control systems in there.
Hey, orange shirt.
I just want to ask, the issue of languages, is there any particular programming language that Google invested in any particular programming language?
No, absolutely not. Any programming language is fantastic. Once you know one, it's easy to learn a second. Once you know 2, it's even easier to learn a third. If you come to Google, we let you interview in pretty much whatever you want. I've interviewed people in Python, C++, MATLAB, Java, Go, pretty much anything. What we want is for you to be interested in that programming language and to show us examples of cool things that you've done in that language.
And for what it's worth, it's like as James said before, like the expectation is that over your career at Google, you will end up learning a bunch of different languages. It really depends on the project that you work on, the platform that you work on. So, you will have to learn new things, and that's, we just want you to be good at one so that we know that it'll be fairly easy for you to move to others.
Can I